So welcome to module 5 of this Pawsey Supercomputing user training series. The topic is using software modules, and this is module 5 out of 11 of the series. The learning outcomes for this module include describing the main software categories that are available in the Pawsey Software Stack. What is a module system and why it is useful for users of a supercomputing facility. We're gonna cover the basic usage of the module command to interact with the software modules, and that's basically it. There will be quite a few hands-on and exercises in this one. So watch out for these signs throughout the presentation. They will highlight key callouts for the module. Just a couple of opening slides just to talk a bit about available software on Cetonix. Just good to highlight this little bit of jargon that we're using. So a software stack, when we refer to software stack, we're referring to a collection of packages which may also have mutual dependencies between them and that are available and installed on a given system. When we talk about dependencies, the typical scenario is that an end-user application of in a given domain may depend on other packages. Like, for instance, it will depend on the compiler for the compiling process, but may also depend on additional libraries for specific functionalities, and in which case the libraries is needed also at the time the application is run at runtime. So how does the software stack look like on Cetonix from a very high level? So there is all of the software stack is organized using system modules, and we're going to talk a lot more about this very soon. The idea is to be able to keep things tidy. I mean, again, it's a shared supercomputer with hundreds of users accessing from many different domain areas with different needs. So there are tens and tens, if not hundreds of packages installed. We can't just have them all available at once at login. It would become not only messy to use, but also very much error prone and prone also to conflicts and issues in actually just setting up the stack. So that's why we use modules to keep things organized and tidy in the system. And there is a variety of modules available. Some of them are provided actually by the vendor of Cetonix, HPE Cray, things like compilers, libraries, and tools, but also developer applications such as debuggers, profilers. Then there are scientific software modules set up by us, the Pawsey staff, for system-wide usage for all users that wish to use them. They are located under /software/Cetonix. This is an information that you won't need to use that much, but just for your own reference. If you want to picture where those packages sit, all of the interactions with software will be using modules, which don't need you to provide this part. As I mentioned in a previous module, there are also spaces available for research teams and individual researchers to install their own software. They are both under the /software/projects directory. So there is a level of the directory tree, which will be the project ID of your team, which can be used by everyone for shared installations, but there are also individual subdirectories for each user account that can be used to that end. And one final bit, this is something we're going to cover in the next module. Some of the modules are actually deployed as containerized installations, such as traditional software builds. This is just a one-shot slide around how to install your own software. There are way more details on this in the user documentation in the section called How to Install Software. This is just meant to provide you some very broad and high-level directions in this topic. This is not the main topic of the module. So we recommend a variety of options for installing your software. The key one we recommend is using a package manager called Spec, which is what we have used to install the majority of scientific applications on Cetonix. It automates the process of encoding a recipe to install the package, to create module files to use those packages. So every time a recipe is available already for a package of interest, that's definitely a very good option to consider. For software with complex build processes or that requires specific version management with lots of dependencies, we recommend using containers. For Python, we recommend using pip or conda if you wish. And for R, we recommend using the R package manager or conda if you wish. If your need doesn't fall in any of these categories, there is always the option to manually compile the software using the build tools that are provided on Setonix. This is all about building the software in this module. We're now going to move forward and talking about using software that is already available on the system. And then we're going to talk about software modules. So what is a module system? It is just a software utility that is used to organize and manage a large number of software packages and versions at once in a machine. And the module system achieves so by using software modules, which is a specific item within a module system that modifies the shell environment in your terminal, in your terminal session, to make the corresponding software package available for you to use. So this is how modules become kind of useful to keep things organized and tidy, and then to select and activate the modules for the packages you need to use, and only those ones. So all Pawsey supercomputers currently use the module system called lmod. This is just for your reference. The shell command, the key shell command to interact with software modules is the command module. And after this brief introduction on what modules are and why they're useful, let's give it a go with a hands-on session. So this is again a demo, so feel free to follow. There will be exercises for you to try after this part. So let's get started. First of all, I need to log in again into the Setonix login nodes, the SSH command. So let's start with a couple of quite useful module commands. One is module list. Module list outputs the list of modules that are already available and loaded for you to use at login time, or actually at any given time, at any given time when you issue the command. And by running module list soon after login, we discovered that some modules come preloaded at login. Some of them, it's not super important to know about all of them. Let us just mention that some of them are provided by the vendor of Setonix, CrayHP. Some of them are provided by Pawsey staff for additional configurations and utilities. Some key modules to keep in mind here are the programming environment, which is the GNU one by default, which is the one that provide the compiler for building software, as well as all of the other dependencies that are needed to build software other than a compiler. Tied together with the programming environment, there's always also the actual compiler module itself, which is GCC when the programming environment is GNU. This is the compiler pair of modules that you get at login. So GNU GCC is the default. There are other options available, which I'm probably going to show you soon. Other modules that are notable are the CrayP Milan module, which just activates compiler optimizations for the Milan architecture of the CPU nodes that are available on the Setonix compute nodes. And another notable one is the CrayMPitch module, which is the module used for building and running MPI parallel applications on Setonix. So this is about module list, so showing what's currently loaded and available as modules. Let us now use module avail. So module avail is useful to browse the collection of available modules. So modules that are not necessarily loaded at this time, but you may wish to load in order to use the corresponding package. And so let me get started with module avail without arguments. This will be quite messy, because there's quite a few modules loaded on Setonix. Let me scroll with Control F we don't want to comment on this list. It's quite long. There is a lot available in there. So the best way to use module avail is actually by adding one extra argument, which is a string that will that module will use to search within the full collection of modules. And for instance, we could do module avail PRGM. And in this way, we get to know that there are 3 programming environments available on Cetonix: AOCC, the AMD compilers, Crave, the Crave compilers, and GNU with the GCC compilers. The third one is the one that is loaded by default at login, as we just saw. Let me give you another example. There are also domain-specific applications available. This is just an example from quantum chemistry and WChem. Here we go. Another example that is notable is Python. There's quite a few Python variations available. And actually, the module avail command will search for the string, not necessarily at the beginning of the module name. So sometimes you can get also some kind of spurious outputs, but some key information, say here, the Python interpreters that are available, 2 versions, and the IPython improved console, which is also available. And you see that in this case, Python is not at the beginning of the module name, but it's still output as a result of this command. Okay. Oh, what happens if I look for something that is not available? Module avail foo will say, yeah, no module found with that string. Let me go back to the slides. Here I'm just covering in these slides what I just commented during the live demo. So I'm just skipping through. And module avail. Okay, now second part of important commands for modules, it's module load and module unload. After you have identified a module of interest, in order to use the corresponding application, you need to load the module. Let's give it a go. Say I want to use the NWChem program that I showed you earlier on to be available as module. Is NWChem available as I log in? Well, if I type NWChem, it says command not found. Alternatively, I also can use which NWChem, which will print the location of that specific binary name, application name, and it says, yeah, no, the NWChem found in the search path. But I know there is a module for NWChem. So let's go with module load NWChem. And I'm getting an error. So why is that? So that's because on Cetonix, we have disabled the usage of default module versions. It means that every time we try and load an application module without the version of the module, we will get this error. You need to load the module as name/version. So let's try again. We just saw that there is just one version on NWChem. So after slash, I will just use tab autocomplete to get version 702. So now I'm loading the module. And now if I search for the NWChem application, you can see that it's indeed found in this new path that was added to the shell environment by loading the module. And you can also see that the module is loaded by using a module list. And now NWChem is in the list. I would also notice that another bunch of dependency modules have been loaded by NWChem. This is stuff that can be useful at runtime with an NWChem. And especially useful, so you can see there are, for instance, some performance libraries such as Scalapa, and Blast that are needed by NWChem. One notable, we added these dependency modules in the loading mechanism for people that need to develop and compile and build their own applications. One important aspect to mention is that we set up module builds and software builds on Cetonix with spec to improve reproducibility of the workflow, of your workflows and your runtime. So these dependencies are actually encoded in the NWChem application at the time of building. So there is, say that NWChem needs OpenBlast 0315. When you use NWChem in this module, it doesn't matter whether this module is loaded or not. NWChem knows where to find its dependencies anyway, because of the way we compiled NWChem to start with. So that we did that to improve the reproducibility of the runtime. So there's no way that if you load the wrong modules, you can make things non-reproducible. This is just a note, especially for those users coming from Magnus, where that was kind of a potential issue. So back to NWChem, the executable is found, the module is loaded in the module list. We can now also unload the module if we wish. And now the module is gone. And in fact, NWChem is not available anymore in the shell. So that's how, this is the basics of loading and unloading modules to make programs available for you to use. And now back to the slides. This is what I just told you. So an important best practice is always specify both name and version when using module command. This is a requirement for Pawsey modules. It's also good actually for reproducibility, because it means that when you script your workflow, you are forced to think about the version you want to use, and the version is recorded in your scripts. Now there's an exercise for you. It's a lot of questions, but it should actually flow quite quickly. Give it a go. This is designed to make you play with module avail and with module load and unload. I will get back and go to the outcomes of these exercises in a couple of minutes. Okay. So let me go to the outcomes. I'm going to do this one live as well, because I think it's quite good to familiarize together with the module commands. So the first question was query how many GROMACS versions are available on Cetonix, and then you can achieve that by using module avail and then GROMACS, which, by the way, is another computational chemistry package for molecular simulations. And you can see there are 2 versions available on Cetonix. Let me go through the example with CMake. So CMake is a build tool that's used by many software packages to perform the installation, prerequisite steps of the installation. By default, when you log in on Cetonix, there's a quite old version 3.17. Let's see if there's a newer version available as module, and there is. So we can actually perform module load, and let's do this first without version, just to remind that you need to specify the version as well. So let's repeat with the version as well, 3.21.4. And now if you go for CMake -- version, we are using the newer version as provided by the module. And then it's actually not in the questions, but you can see the CMake module is loaded through module list, and then we can unload. And the module is gone, and the available CMake is back to the older version as found at login. Okay, so let's move back to the slides. This was just the output that I went through with you on the terminal. One last bit around software modules. Let's talk a bit about module hierarchies, which can be handy when handling complex software stack. And in particular, compiler dependencies. So a module hierarchy, it's a feature and a mechanism within LMOD, the module system that we use at Pawsey, to filter the available modules that get output based on their dependency on a small set of key modules. And the example here will be the compilers. So say, as we have on Cetonix, we have 3 main compilers, GCC, AOCC, and Cray. We don't want to output all of the packages available with all compilers every time we use module avail. That will make the list even longer. And so we configure the LMOD module hierarchies to play on the compiler dependency. And in this way, when we use module avail, the output is filtered by the currently loaded compiler. And let's see this one in action. Just one important thing to mention is that modules provided by the vendor, by HPE Cray, use hierarchies also for other contexts, such as MPI, network, libraries, and other things. You won't get to use that one as often. The key one to keep in mind, the functionality, the key use for module hierarchies is for the compiler. That's what we're gonna likely jump on more often. And we can swap between hierarchies by using the module swap command. So when we perform a module swap on the compiler environment, we're not only unloading the old compiler and loading the new one, but also telling LMod, the module system, hey, you're now gonna follow the hierarchy for that new compiler. And let's see how that plays. So let me just clear up the screen and remind you that by default on login, we are using the GCC GNU programming environment. Now, let me load the Python module in this setup. We have a Python 397 available, and we can spot that module list. But crucially, if we go which Python, we'll see that we are pointing to this Python 397 is installed by Pawsey on the system. And if you have a look at the directory path of this Python 397, you will see that this was compiled with GCC, with the GCC compiler. Now, let's swap from the GNU programming environment to the Cray programming environment and see what happens. So you see that when you swap, LMod is also replacing the compiler module GCC with CCE. And crucially, LMod is also automatically reloading and updating other modules that depend on those compilers. And one is Cray MPI, but crucially, one is the Python module I just loaded before the swap. And so let me show you what this looks like. So in the module list, you now have the Cray environment and the CCE compiler, as was also commented in that output. The Python module looks like it's the same because it has the same name, but this is the power of hierarchies to keep these things concise. If you go which Python, the Python we're using now is the one built to the CCE. So, and that's how hierarchies get useful. With LMod, you swap compiler, and a program that you loaded that was depending on the previous one gets updated to the new compiler. Now let's swap back to GNU. And now the vice versa basically happens. So we are automatically switching back to the GCC Python. So this was the case of Python where the installation is available with both programming environments. Now let's try another case, which is actually again NWCam. So we here have NWCam as built with GCC. Let's now swap to Cray again. What happens? We now have an output saying inactive modules. So some of the modules that were loaded before have become inactive. And this includes NWCam and its dependencies. And we can confirm that here. So in the module list, we now have CCE and Cray as programming environment and compiler, but NWCam has gone inactive. Can I use NWCam now? I can't. There's no NWCam found. And that's because NWCam was not compiled with Cray on Cetonix, so it's not available in the compiler environment. So again, hierarchies manage that for you. If you're switching to a compiler environment where some packages are unavailable, they will be inactivated for you. So now if I go back to the original one, GNU again, those modules get reactivated for you when you swap back to the GCC hierarchy. That's where NWCam is available, and it's back available for you. Okay. This is how, under the hood, this is how we manage the complexity on Cetonix to keep a software stack that is built with multiple possible compilers. And module swap within LMod makes handling this quite straightforward and with no extra steps needed by the user of the machine. Okay, now we're back fresh to the original state. Let me go back to the slide. This is just the output I showed you. This is just a summary of what we saw in terms of useful command within LMod: module list, module avail, load and load as swap. Another couple of commands that can be useful, I'm not demonstrating them now. It's module what is and module help, followed by the module name. This will provide additional information as provided within the module file during the process of creating the module files. This can include, say, available commands, versions and build options, and what the application actually is, in case you don't know. Finally, because module has so many different functionalities, you can always review them by just typing module help. You get the output, the help output screen for module itself. Okay, this is one of the few cases where I'm just giving a brief note on other Pawsey clusters that are gonna be decommissioned in the coming months after the full Cetonix deployment is completed. So on top of Zangara-Walla, we have again LMod as the module system. If you try module list there, you will see that the list of loaded modules is much shorter. So this is a difference. Another notable difference is that on those older clusters, when software has a dependency, the dependency is not encoded at build time. It is actually decided at runtime. So in those older clusters, you need to be careful in case you load. So some module loads can interfere with the actual reproducibility of your run if you are inadvertently changing the version of one dependencies. So this is a notable difference on the older clusters. And finally, module hierarchies. So the module swap functionality I just showed you for Cetonix is not implemented on those clusters. So it's swapping between compilers is not as automatic. The typical way to do it is to unload the module that you've loaded first, change compiler, reload the module. So back to Cetonix and generally for Pawsey, just some considerations around the software stack. We do support and provide pre-installed software modules for a number of applications within many scientific domains. We recommend those ones to use those ones if they fit your workflow because they've been optimized for Cetonix hardware. Pawsey does not pay for licensed software. We adopt a bring your own license model. So we do have an unlimited number of pre-installed modules that to which we can grant access to users if they provide proof of license. And we provide general guidelines on installing some softwares on the user documentation with general directions. But for licensed softwares, the license must come from the researcher group. And as I mentioned before, we do provide extensive documentation on how to best build any software on Cetonix, especially for the case where we don't support the build directly. So this is the user documentation for installing is the main support we provide for software that is not available already on the system. We may provide additional assistance to install software, but which is not supported, but this is discretionary to us. We evaluate it case by case. We typically give support, give priority support to some strategic initiatives and projects we do have at Pawsey. This module, we learned a bit about software stack at Pawsey, the module system, and the various module commands. We demonstrated in details the key commands that are needed to interact with the module system, and I provided you with some best practices on module usage. At Pawsey, we have a support portal online with extensive user support documentation that covers many areas in detail. as well as the user support portal. Researchers that need help and assistance with issues and that wish to get in touch directly with Pawsey staff can reach out to the support portal. If you want to stay updated with news and events, you can subscribe to the Pawsey Friends newsletter. So this module is finished and the session is open for questions. Thank you.